All right, so right now we are going to bubble sort our list. Now, to refresh your memory, the way bubble sort works is that we look at adjacent pairs of items, right? Say this is our list. And the way this works is that when we do bubble sort, we look at adjacent pairs, and if the pair is out of order, we swap them, right? So let's take a look. 1 and 5, are they out of order? No, so they stay the same. 5 and 6, they're not out of order, so they stay there. What about 6 and 2? So we'll swap 6 and 2. So 1, 5, 6, so 2, 6, 4, right? What about 6 and now we go on to the next pair. What about 6 and 4? They're out of order, so we swap them. Okay, and so we're done with our first iteration of bubble sort. And the reason it's called bubble sort is because after we've done one iteration of bubble sort, we can be assured that the biggest number has bubbled to the top, right? 6 bubbled to the top position. Okay, and if we run it again, then we can be assured that the second biggest number, which is 5, will come into the second biggest position. So if we run it again, let's look at 1 and 5, right? They're in order relative to each other. What about 2 and 5? Well, they're out of order, so we swap them. What about 5 and 4? Well, those are out of order, so we swap them. What about 5 and 6? So those are in order. And we do that, and now we know it's in order. But for right now, and if we were doing an optimized version of bubble sort, we could stop there. But right now we're going to do an unoptimized version of bubble sort. And with bubble sort, right, if we look at all these pairs, right? And we notice that so we do bubble sort once, we get one item in its final place. We do it twice, we get the next biggest item in its place. We do it again, we get the third biggest item, then the fourth, and then the last item comes for free. So if we do this, if there's n items and we do this whole run n-1 times, then we'll be assured that it works. Okay. So for int I is equal to 0, so let's go with let's see, actually make it more descriptive. We're going to go ahead and call this runs. How many times this needs to run? It needs to run list.size -1 times because at most. And then each run, what do we do? For int I is equal to 0, I is less than the list.size -1. Why that? Because we're looking at each adjacent pair, so we need to look one to the right. We'll go ahead and say so let's go ahead and get the left and right of each pair. E left is equal to list.get the item at index I, and the right item is the item at I plus 1. And finally, what do we need to do? Well, if left dot compare to right. So how do we know we're out of order? Well, we want left to come before right, or at least for them to be equal, right? So if left comes before right, we'd get a -1. So if they're out of order, we'd get a +1, or a number greater than 0, rather. So if left dot compare to right returns 0, then we know that we're out of order, right? Because that would mean that left should come after right. Okay. So if that's the case, then we just simply do list.set I to right. We just swap them, and we do list.set I plus 1 to left. Okay. So that's it for how Bubblesort works. Right, so let's go ahead and just test it to make sure that it works before we move on to analyzing Bubblesort. And I definitely need to cut that down to a smaller size. Print this out. Print list sort list, and we run it. We'll get 2 lines. Oh, we're getting negative numbers, so I guess it wasn't making it positive. Interesting. But they are all in order, so that's good. Wonder why it didn't make them all positive. Interesting. Well, easy enough to fix later on, but doesn't really matter for our purposes. But it's got them sorted. So that works. So we'll analyze this in the next video.